Awesome. All right, everybody. So again, my name is Steve Stratton. I'm here with Diesel Emission Service. First, I'd like to take a quick second and thank NARSA for the opportunity to speak about the NARSA and IDEA for the opportunity to speak about aftertreatment. Our aftertreatment presentation is generally 4 hours long. So we've condensed it down from 4 hours to about 35 minutes. We're going to call this part one of essentially many presentations. I've been with Diesel Emission Service, our company, for 17 years, and I have been in the emissions industry for 14 years. The majority of my time I've spent with the company is in a service, a lead service role, understanding what the systems are. I've found that they are a lot easier than they may seem. So again, what we're going to go over today is some very basic after treatment information, what some of the major components are, what do they do, how do they work, and why do they do what they do, and then some how to service them information. Again, everybody's mic is muted. If you have questions, please feel free, excuse me, to post them in the comments. Okay, so as we get started, everybody can see my page, right? All right, cool. So first things first, we're going to start with some system configurations. On the left-hand side, we have a on-highway heavy-duty after-treatment system, and on the right-hand side, we have a light medium-duty application after-treatment system. Some components, basically what we want to get across in this picture is some of the components may look different. They might be in a different layout, but it's after treatment is essentially the same across the board. So if it's light medium duty, on highway heavy duty, or after treatment, you're going to see DOCs, DPFs, and SCR systems. Okay, so for instance, starting with the, excuse me, let me get my laser pointer here. Excuse me. Some of the components we're going to see right out of the gate is right off the end of the turbo, we're going to see a engine outlet NOx sensor. We'll see an after treatment fuel injector. Then we'll see the DOC inlet cone. A DOC inlet temp sensor is generally here. We have the DOC, a DOC outlet temp sensor, which is also known as a DPF inlet temp sensor. We have the diesel particulate filter, or DPF. We have a DPF inlet temp sensor, which is, again, also the DOC outlet sensor. We have the DPF pressure differential sensor. It's reading the pressure differential across the inlet and the outlet of the DPF. And we have an outlet DPF sensor, outlet DPF temp sensor, excuse me. We have the SCR injector, or DEF injector. We have a mixer module, some people call them decomposition reactors, decomposition tube that the SCR is injected into. We have an SCR inlet temp sensor, the SCR catalyst, an SCR outlet temp sensor. Then we'll see a outlet NOx sensor. You should see on the outlet side on 2018 and newer, some models have a particulate matter sensor. And then we'll have a DEF tank with the DEF injection system, and then the DEF lines here. So first things first, what is a DOC? A DOC is, or diesel oxidation catalyst, is a device that converts exhaust gas pollutants into harmless gases by means of chemical reaction. So in the case of diesel exhaust, the catalyst is oxidizing carbon monoxide, which is a colorless and odorless toxic gas. It is also oxidizing hydrocarbons. So the diesel oxidation catalyst is promoting chemical oxidation of CO and HC, right? As well as some organic fraction of the diesel particulates. The diesel oxidation catalyst is a vital part of the after treatment system. The most important function of the DOC is to increase the NO2 content of the exhaust gases. This is to support the SCR catalyst and the DPF's ability to oxidize soot and lower NOx. The DPF regenerates, oxidizes soot, and the SCR is the NOx reduction technology. That's the main function of the DOC. Diesel oxidation catalysts are flow through. That means the exhaust flows straight through the honeycomb, excuse me, with very little restriction. They're built much like a catalytic converter. What that means is if you were to hold it up to the light, you would be able to see straight through it. They're typically made of either a cordierite material or metal mesh. Cordierite material is similar to what the DPFs are made of as well. Okay. The diesel oxidation catalysts are coated with precious metals for regeneration and positioned ahead of the DPF. The precious metal coatings are generally, we're going to see platinum, palladium, and rhodium coatings. The picture that we have here on the screen is of a 2000, excuse me. The picture we have on the screen here is of a 2009 Cummins DPF with the DOC. We have a inlet cone, the diesel oxidation catalyst, DOC inlet temp sensor, outlet temp sensor, the DPF pressure differential sensor, DPF pressure differential inlet tube, and then the outlet tube. There's also a DPF temp sensor on the outlet side. This system is from a 2009, but the components carry over to the 2010 and later year models. They just added the SCR to the end of the system. Okay. There are some minor differences, but that's essentially what's going on there. So with the DOC or the diesel oxidation catalyst, the DOC can be serviced at the same time as the DPF, and it should be, right? Common reasons for frequent DPF regeneration are, number one, engine malfunction or DOC contamination. DOC contamination could be from a EGR cooler, injector, cylinder head, bad valve adjustment, right? Any kind of oil bypassing the engine and going out of the tailpipe. Ash accumulation in front of the DOC, right? And that could be caused by a failed after treatment fuel injector, an engine related issue, and then exhaust leaks upstream of the DOC. The DOC needs a couple things to operate. The first thing it needs is heat. It needs heat from the engine, and it needs the hydrocarbons or the fuel source coming from the after treatment fuel injector. If you have an exhaust leak upstream of the engine or upstream of the DOC from the engine, if the heat can bypass the DOC, which leak out, or the fuel can leak out, that could cause frequent regeneration, excuse me, frequent regeneration or DOC issues. So inspecting the DOC for issues that could cause premature regeneration is definitely a crucial part of the cleaning process. With any related engine failures, we recommend you inspect the DOC and service it. So one of the questions, how do you service the DOC? First, remove any soot buildup on the face of the DOC. You can bake the DOC to oxidize any of the remaining soot and then remove the ash out of the DOC. So blow it out, bake it, and blow it out again. There is an alternative to the blow it out, bake it, blow it out method, which it's blow it out, wash it with an aqueous DPF cleaning machine, and then dry it. Okay, that's essentially how you would service a DOC. Sorry for the coughing. I've got some allergies going on here. So that's the DOC. Now we're going to talk about a little bit about what a DPF is. A diesel particulate filter, or DPF, is a device designed to remove diesel soot from the exhaust stream of the diesel engine before it's released into the atmosphere. Okay. Diesel particulate filters are a wall flow design. That means that the exhaust flows into the filter through the cell walls, and the soot or the PM is caught as it's passing through. DPF filter cores have alternate channels plugged. It looks kind of like a checkerboard. The plugs create restriction. The restriction forces the exhaust gases to flow through the pores of the brick or through the wall of the filter, and the soot sticks to the cell wall. Okay. There are essentially two filter types that you're going to see on highway on-highway applications. The first filter type, the most OEM filters are made of a cordierite material. Cordierite filters, excuse me, cordierite filters provide an excellent filtration efficiency. They are strong in large pieces. You're able to make them in many multiple sizes. They've been known to melt during regen as one of the downsides, and that is generally due to their low temperature profile and engine-related failures. Cordierite filter cores, again, they have alternate channels plugged. Those plugs force the exhaust gases to flow through the filter, through the pores of the brick, and the soot will, again, collect on the cell wall. They are relatively inexpensive. That is compared to the other types of substrates, which we're going to mention here. And I use that term relatively very loosely, because we know they are not that inexpensive. The second type of filter is silicon carbide, or SiC. A lot of newer trucks you're going to see with this type of filter. A lot of off-highway equipment have silicon carbide, and a lot of your light medium duty trucks have silicon carbide. The reason they have silicon carbide is it has a much higher ability to hold soot and a much higher temperature profile, so it can handle a more severe duty cycle without having major engine failures. They generally don't melt, excuse me, when you have a minor engine related issue. Again, its melting point is much higher than cordierite. Silicon carbide cores are made in segments which are bonded with cement. That cement is allowing for heat expansion and contraction of the core. They are fairly weak in large pieces, okay? And they are quite a bit more expensive than the cordierite material. So what does the DPF do? Diesel particulate filters provide a minimum of an 85% PM reduction, and under most conditions, they attain soot removal efficiencies of 100%. The inlet of the DPF should always be dirty. The outlet should always be clean, okay? They're designed to oxidize the accumulated particulates either passively through the use of a catalyst and the engine's exhaust temperature, or actively through the use of the engine's exhaust temperature, a catalyst, and an outside heat source, okay? Heating filters to soot combustion temperatures is known as filter regeneration. It's also known as thermal management. When the DPF system goes into regen, that's the thermal management kicks in. The ECM is monitoring fuel rates and kind of what's going on, and it maintains temperature to oxidize soot. That temperature is generally right around 1,000 degrees. You will see temperatures higher and lower, but it's generally right at 1,000. So again, what is DPF regeneration? Regeneration is the process of burning off or oxidizing the accumulated particulates from the filter. This is done either passively from the engine's exhaust heat in normal operation, or by adding a catalyst to the filter, or actively introducing a very high heat to the exhaust system. Every DPF manufacturer has their own process for regeneration. So the actual temperature for regeneration, excuse me, it will depend on what type of catalyst is being employed there. So keep in mind, not many manufacturers use actual flame for regen. Some do, some Hino, some light medium systems do, but not many. They use fuel vapor, either with an after-treatment fuel injector, or they use a fuel injector with in-cylinder regeneration. I'm not really going to touch too much on that stuff because that's going to be later on in another presentation. So moving on here to SCR, or selective catalytic reduction. SCR, or selective catalytic reduction, is an active emissions control strategy that injects diesel exhaust fluid into the exhaust stream in front of the oxidation catalyst of the SCR system. SCR, or selective catalytic reduction, is not new technology. This stuff has been used in Europe and mining and agriculture since the early 50s. So again, this is definitely not new stuff. Nope. George, I'm going to go ahead and answer your question. No COVID here. I'm completely safe. And I've got some water. Thank you. I've got a cough. I've got some allergies going on. So my apologies, guys. So why do we use SCR? We use SCR to lower NOx out of the diesel engine's exhaust stream, okay? Nitrogen oxides, or NOx, they're generated from nitrogen and oxygen under high pressure and temperature from the engine. NOx consists mostly of nitric oxide, or NO, and a small fraction of nitrogen dioxide, NO2. Nitrogen dioxide is very toxic. So NOx emissions are a serious environmental concern because of their role in the formation of smog. The SCR catalyst is flow through, just like the DOC. Okay, so NO2 come in along with some NH3, which NH3 is ammonia. It comes in, the SCR catalyst converts the NO2, and NH3 to nitrogen, which is N2, and H2O, which is water. Okay, so diesel exhaust fluid. DEF fluid is what's used to lower the NOx or convert it. DEF fluid is injected upstream of the SCR catalyst into the exhaust, typically when the temperature is above 350 degrees. It's typically above 350 degrees. The DEF fluid is 67.5% water and 32.5% urea. Okay, the urea converts to ammonia. The ammonia has a chemical reaction with the SCR catalyst to convert that NOx, NO2 and NO, and NH3 to nitrogen, into, and water, H2O. So that 32.5% solution of DEF will crystallize and freeze at 12 degrees. At that 32.5% ratio, 32.5% urea, 67.5% water, both the urea and the water freezes and thaws at the same rate. So there is no, it's important because when it freezes and thaws at the same rate, it ensures there is no dilution or chemical dilution of the water urea concentration. If you're outside of that range by more than 1%, you can see some issues. So when you're in a real cold climate, excuse me, and your DEF fluid is outside of that 32.5% ratio, you could see some chemical dilution there. In this picture, in this representation, this is SCR at work. The engine creates NOx. The engine's creating soot. It's creating all the harmful particles that are coming out. So the engine creates soot. The DOC and the DPF oxidize soot. The DOC does have some NOx reduction technology, not much, but some. The DEF system, the diesel exhaust fluid, is injected after the DPF in front of the SCR catalyst. The SCR catalyst is after the DPF system here. So again, the SCR catalyst is flow through, just like a DOC. The SCR system has service items. The first service item, or the most important one, really is the filter, the DEF fluid filter. That fluid filter is located in the module, the DEF fluid module. Okay, the DEF dosing unit that houses the filter, that filter will need to be serviced. Manufacturer says every 200,000 miles, or as part of routine maintenance. Our recommendation is you pull and service that filter at least once a year. This particular DEF doser, DEF module that we're looking at here, that is the Denoxtronics 2. That module has about 80% of the market share. So your on-highway trucks are generally going to have this module. Cummins, there are some manufacturers that have different ones, but generally you're going to see this particular module. So one of the most asked questions we get is, can you clean the SCR catalyst? The answer is absolutely yes. You want to clean the catalyst when there is a buildup of DEF right? Or the DPF is bypassing soot. There are two ways to clean this catalyst. The first way to clean it, and the easiest, is to bake them, right? When you bake them, the DEF fluid, when heated to 1,000 degrees, it essentially dissolves. The second is using an aqueous cleaner with warm water. DEF fluid will, when it crystallizes, it will wash away or break down generally with just warm water. So if you get an excess buildup of DEF on the decomposition reactor or on a decomposition tube or in the catalyst, you can bake either one. Of course, remove the sensors and make sure that there is no plastic or rubber. And you can bake either one, and you can wash either one with warm water. With warm water, excuse me. Okay, so that's a little bit about DOC, DPF, and SCR. Next, we're going to talk about some DPF service and recommendations. There are a lot of cleaning options out there, right? There is no one-size-fits-all application. There is no one-size-fits-every DPF cleaning available, right? So every DPF cleaning machine you're going to run into, you'll find there are some features and benefits that others have that some don't, right? Which is why we suggest it's the process that you follow versus the machines you're using, right? As long as the company follows a process, they should be able to deliver a clean filter. The process that we recommend, our process, is very simple. First things first, documentation. We want pictures of the filter. We want info before the cleaning as well as after the cleaning. We want inspection. What's going on with the filter? What does it look like? We weigh the filter. Some people ask, well, why do you weigh filters? We weigh filters because we want to know how much ash is being removed. I'm going to talk about that here in a couple more slides, but we want to know kind of what's being removed from the filter. We're going to wire test the filter, or pin drop test, some manufacturers call it. Bake the filter and de-ash, bake the filter and de-ash it, or wash it and de-ash it. Okay, then we're going to rewire test. We're going to flow test again. And then we're going to inspect and document everything we find, okay? John just asked a question. I'm going to answer this question now. I plan on answering it here in a few slides, but I'll give you a real quick bit of information. When you pin drop or pin test a filter, you're checking to see what kind of restriction is in it. Is it hard ash centering? Is it soft, powdery? Is it wet? That's going to tell you right out of the gate. If it has hard ash centering or it's melted, that filter may just need to be replaced. No need to waste time getting it cleaned. If it's not centered, doesn't have hard ash centering, and it just has white ash or a sticky filling, if it's sticky, maybe it needs washed. If it's dry powdery, it's just due for general cleaning. So that's essentially what the pin test is going to tell, that's what the pin test is going to tell you. Okay. So how do I know I need to service my DPF? Most OEM suggests cleaning filters between 200,000 and 300,000 miles or 4,500 hours. A proactive suggested cleaning intervals are between 50, 70,000 miles or 1,000 hours. We recommend 1,000 hours once a year, 50, 70,000 miles, whichever comes first. Or the service DPF light's active on the dash, there's a noticeable loss of power, any major engine repair. Any major engine repair could be EGR cooler, oil cooler, cylinder head, head gasket, right? All of those things is considered a major engine repair. We recommend cleaning that filter anytime one of those things happen. The list does go on, but that's the short of it. So in this picture, notice how much more ash there is in a filter that relies on active regeneration. Active regeneration uses more fuel. The more fuel you use, the more soot is going to build up in the filter, the more ash content you're going to have. So typically if a filter is not pulled and de-ashed, the ash that is accumulated in the filter is going to restrict the flow. This essentially causes poor fuel economy, increased downtime, tons of potential engine issues. Ash is made up of minerals, metals, and trace elements from the breakdown of lubricants, additives, and engine wear. So as the ash builds up, the ash in the filter builds up at a much slower rate than soot. So if it's ignored, it will eventually cause an increased back pressure. It's going to cause fuel consumption and sometimes DPF failures. Ash builds up inside the DPF. As ash is building up inside the DPF, the number of active regenerations is definitely going to increase, and that's going to cause poor fuel economy. High intake temperatures and exhaust temperatures, as well as consistent back pressure. High back pressure causes crankcase pressure. Crankcase pressure causes oil leaks, right? And that high back pressure can be detrimental to a VGT turbo. So whatever we can do to decrease the amount of back pressure and increase flow is definitely going to increase the life expectancy of your after treatment system as well as the engine, okay? Sintering or hard ash sintering. Sintering occurs in filters where ash has accumulated for an extended period of time. If left unserviced, the ash can harden, damaging the filter and causing high back pressure or BP, as well as engine issues. So what that means is the ash, essentially what ash is, the metals that are found in lube oil will melt under high temperatures. Ash has trace elements of aluminum, iron, magnesium, zinc, copper, right? All of those metals, when heated, can melt. They stick to the cell wall or stick to the substrate and decrease the amount of flow, which increases back pressure, okay? All of this can be, centered filters can definitely be avoided with a proactive service interval, which is that 50, 70,000 miles, 1,000 hours, or once a year. So getting into the cleaning or service process. Inspection, DPF inspection. Inspect the filter for internal and external damage. No damage is too small to note. Cracked welds, broken brick, or dents. If the filter has a cracked weld at a flange, if you look at a DPF, the flanges are the weakest, essentially the weakest link. It's the only area on the DPF that doesn't have insulation, which means heat can be lost through it, right? So if you have a cracked flange or a cracked weld bung, you have a heat loss. If you have heat loss, you have poor regeneration, okay? If a filter's damaged, it should not be cleaned. A replacement is necessary. I think that's fairly obvious, but there's some things to think about there. If it's a weld bung that's damaged, those can be replaced. You don't have to replace the entire DPF, right? So again, with the DPF inspection, we recommend taking pictures along the way. Keep in mind, if it's smoking, it's broken. The filter itself should be clean on the outlet and dirty on the inlet. It should never be dirty on the outlet side. Okay. If it is bypassing. We need to figure out why. Oh, something's going on here.
The poll that just popped up, just minimize it.
Okay, there we go. All right, sorry about that. Wet filters. First things first, you should never bake a filter that's dripping wet, especially if it's dripping with coolant, oil, or fuel. Coolant has glycol in it. Glycol is flammable at 1,000 degrees. So when we heat filters to soot combustion temperatures, right, there's a chance that we could send that filter into an exotherm or melt. So we want to use caution when servicing wet or soaked filters to avoid damage, right? We don't want to damage them or the equipment. If a catalyzed filter, DOC or DPF, comes in contact with oil, the catalyst will be poisoned and no longer regenerate. If it's an uncoated filter, it can be cleaned. Generally speaking, DOCs are not uncatalyzed, so DPFs would be uncatalyzed. Those filters, generally speaking, if it's uncoated, it can be cleaned. Wet filters are recommended to go through a dry out cycle. We heat the filters to temperatures that are hot enough to dry out the VOCs or the volatile organic compounds that make up the fuel source, not hot enough to ignite them, okay? Filters that have been saturated with oil, fuel, coolant, they may be poisoned. The only way to know is to put them in a truck and watch the regeneration process. Watch the process. Is it making temperature? Is there chemical reaction with hydrocarbons? If it is, it's working, it's going through regen. We don't know how long it's going to last, but it is working. If it's not, then it's due for a replacement. Okay. Weighing the filter. Remove any and all road grime off the filter. Oh, okay, I've got to hurry. So I'm running low on time. So we're going to remove any and all road grime off of the filter and weigh it. We want to know what it weighs because that weight is ash. It's either lube oil ash or fuel ash, right? It's lube oil or fuel. Is it consuming an excess amount of fuel or is it burning oil? That's going to help technician kind of know which way to go with their engine repair diagnostics. Wire test. So we're going to insert a stainless wire into the filter inlet. We're going to note how far the wire travels into the cell and what kind of resistance there is in the filter. Is it hard ash soot? Is it hard ash? Is it soot? Is it white ash? We recommend using 030 stainless TIG rod. You can get that from any local welding supply store. It's small enough to fit in just about every substrate. That wire should travel to the bottom of the filter with very little restriction, okay, or resistance. If it does not, or you don't know how far that wire should travel into the filter, flip the filter over and wire test the outlet side first. The outlet side of the filter should always be free of restriction. Mark the wire, pull it out, put it into the inlet, okay? Once you've done that, there are 4 feelings that you're going to find with the rod, and this is why it's so important. First one, hard crunchy. That hard crunchy feeling is going to, it indicates that the filter is melted or there's hard ash centering. We want to know if it has, if it's sticky. Sticky indicates that the filter is wet and it most likely needs a dry out cycle. Powdery, nice and soft and smooth, you can feel the powder. That tells us that the filter is most likely operating properly and there's no issues. A general cleaning should be fine. And the last one, it's going to be nice and smooth. It should feel just like the outlet side. What that indicates is that after you've cleaned the filter, before you start the process, you wire test it. After the process, you wire test it again. Is it smooth? If it's smooth, it should feel just like the outlet. That means the filter's nice and clean. If the filter is more than 1/3 restricted with hard ash centering or it's melted, if it's melted, we recommend replacement. But if it's restricted with more than 1/3 hard ash centering, we recommend a replacement as well. And that's because of you're 1/3 restricted You have less surface area, less flow for your engine. You're gonna have frequent regens. You're gonna have nothing but potential issues down the road. Okay, flow test the filter using the best technology available. You can find flow rates for most filters by contacting Filtertherm, Redline, or FSX, or whatever type of cleaning equipment you guys are going to use or your company uses. That manufacturer should have flow numbers available. I know that they are pretty much standard from Filtertherm and excuse me, FSX. Okay. Baking the filter. Every manufacturer has a temperature profile for baking. Bake the filter using the appropriate settings. Some companies don't bake every filter. We do, and we recommend it because we want to ensure that all of the soot is oxidized and ash is removed before it's reinstalled. Ash builds up in the filter, soot covers the ash builds up behind it. Sometimes just blowing it out doesn't get all that ash out, so we recommend baking it. There's another cleaning method that I'm going to touch on briefly. It's aqueous or water-based cleaning. Our process stays the same. We would just substitute washing for baking or baking for washing. Okay, once that's done, we're going to, after the baking process and de-ashing process is complete, we're going to insert the stainless wire into the filter inlet. Again, we're going to note how far it travels into the cell and what kind of resistance there is in the filter. As we go through this process, it's going to give us some indication as to whether or not we need to service that filter some more. There's some areas that may need more attention, right? Or maybe another baking cycle is necessary. Then we're going to bake the filter using an appropriate scale. And we weigh those filters in grams. These pictures are essentially some filters that you're going to see or that we would see in our shops. The one on the left is a normal filter. That's the filter that's oxidizing soot normally, this regenerating like it should. The second filter that's face plugged, that is a filter that has a duty cycle that's not conducive for regeneration. The engine is creating soot. The filter can't handle how much soot it's getting, and it just loads the filter and turns on DPF lights. Okay. On those face plug filters, we do recommend that you put those through a dry out cycle first. Okay, some failure modes. The first picture, can you see this, my pointer there? Up here, soot bypassing the substrate caused by lack of maintenance and an engine, excuse me, an engine malfunction. Soot was bypassing the substrate around the filter, not through it, but around past the matting. That filter was at one of our facilities here. The second filter, soot bypassing the substrate caused by a bad injector and lack of maintenance. This particular filter, the customer had an injector replaced by a shop down the road. They didn't pull his filter and clean it. They replaced the injector, sent him on his way. When he got down the highway, his DPF went into regen, it was overloaded with fuel, and it melted. So lack of, one bad injector and lack of maintenance caused that failure. The next one here, soot on the outlet side of the filter caused by a failed EGR cooler. EGR coolers contaminate DOCs and DPFs. Right, so this particular filter needed to go through a dry out cycle. It was caught proactively during their diagnostics. This last one here, soot bypassing the substrate caused by a failed EGR valve and lack of maintenance. EGR valves cause problems. They can potentially overload a filter with soot. If you don't pay attention to those fault codes, you can overload a filter. Excess fuel creates an exotherm or an uncontrolled burn in the filter and damage those filters. Here's some pictures of some more failed filters. Most of these failures could have been avoided, right? This particular filter, water intrusion, it didn't have a correct turnout on the filter. Being proactive, what we need to do is be proactive, not reactive, right? Service the filter before the lights come on. When you or your customer have engine issues, think about kind of what's downstream. So when we think about what's downstream, these particular issues, all of them, again, could have essentially been avoided. So that is essentially it. We're at 36 minutes. That is all the time that I've got for this particular module. There's going to be a lot more. We're going to kind of dig into what is SCR, how does it work, talk about sensors, talk about after treatment fuel injection, all those kind of things separately. And again, I apologize for jumping around, but there will be some more presentations to go in depth. If you guys have any questions that we don't get answered today, you can reach out to NARSA, or you can reach out to REP Direct. And you can reach out to me. My email is jr@des.direct.
Linda open up the mic if she wants, or however she's going to do the Q&A.
Awesome. So yeah, how do we want to do the Q&A portion of it here?
I guess you just read Raymond has a question on the symptoms of chemical dilution in death mixture.
Okay.
Oh, she's just saying you just keep writing questions in the chat. So just answer them as they come.
Okay. All right, so. Okay, so John had a question about when cleaning these filters, do you cut each filter to single them out? It depends on the situation. In the light medium duty application, oftentimes you have to cut the DPF DOC out of the system to put it into an oven. You won't have to do that if you use aqueous DPF cleaning. The aqueous DPF cleaning machine cleans the DOC, DPF, and SCR all at the same time. Oh, Wayne, sorry. Thanks for answering that question.
Joshua Schwartz has a question. The very last one, it says the last slide you had a filter damage as a result of the turbo. Can you explain that here further? Josh is the sales manager at Turbo Solutions.
Yeah. So on the last slide, I can go back. I think you guys can still see it. On this slide, it was a turbo failure. So what happened is the DPF was restricted. It wouldn't go into regen. That back pressure caused issues with the turbo and created a turbo failure. So it wasn't an actual turbo failure. It was a DPF related issue that caused an upstream engine related failure. Raymond, your question, what are some symptoms of chemical dilution in the DPF mixture? You're in the DEF mixture. What you're going to see is you'll get DEF quality codes. You'll get, if you're in cold climates and it's not quite 12 degrees, that 32.5% ratio is necessary because of the freezing rate, right? So if you're saying 30 degrees or 25 degrees and you're starting to see your DEF freeze, why is that, right? So you basically what's going to happen is if the DEF is diluted, you'll get DEF quality codes, you'll see D rates on the side of the road. The after treatment system is going to check and see what's going on. If you have any dilution, it's what it'll do. Bruno asked, if you wash the filter and you're not able to remove all of the ash, won't the ash become solid after it dries? To be honest, I can't answer that question. You also said that you were told that 5% of the filters in the market can be washed. Any filter can essentially be washed. There are certain manufacturers that say you can or cannot wash their product. That's really what you want to pay attention to. If they don't say you can't do it, then why wouldn't you be able to? We've found through testing that the majority of the on-highway trucks the filters can be washed. Aaron asked, cleaning an SCR. If you were to wash and bake, would you wash first or bake first? Well, when cleaning an SCR catalyst, you have options. So you can either wash it or bake it. You can do both. But what we recommend is if you have a washing machine or the company you're using has aqueous DPF cleaning, they should have a dryer. So they should be able to wash the SCR catalyst and then dry it without putting it into an oven. If you have an oven, I would recommend going straight to the oven because you don't need to wash it. It's less work. Raymond, your last question for the one box, is there a way around the code 4364 FMI 18? I can't tell you off the top of my head right now, but I will get you an answer for sure. I will get you an answer.
Well, we need his contact info.
It is Raymond.
Raymond of what?
Where do you think Raymond's from?
Federal? No, where is he in Quebec?
I don't know where he's at today, but yeah.
Quebec. Tell them both Steve say hi.
Both Steve say hi. I'm sure you heard him. Steve Hoke is sitting next to me actually. Edward, thank you. I'm glad you got something out of the information that we're able to give you today.
Heard
Bruno, okay. FSX is the ones that told you that most filters should not be washed. I can't speak on that. I can't do it.
Again, referring to OEM filters, the corporate substrate is okay, and matting, every manufacturer uses the correct matting for aqueous. It's the retrofits that do not.
Okay, I was given permission. So the matting for aftermarket or retrofit DPFs is different than the matting for OEM. And what happens is if you wash an aftermarket retrofit DPF, the matting can break down. So generally you don't want to wash those filters because you could break down the matting and the filter could fall out. OEM, that's generally not the case. Thanks, Raymond. Thanks for noticing my mustache. I appreciate it. Glad you got to hear me talk.
Thank you very much.
Thank you guys again, NARSA and IDEA. Thanks a lot for letting us participate in this webinar. We appreciate it. That is correct. That's probably why they are double the price. Josh, you are very welcome. Again, if you guys have any questions, jr@des.direct, or you can email rep.direct, or you can call our 888 number. How do I do that?
Then
Okay. All right, awesome. Thanks, guys.